Okay, number 2. Here we go. A railroad worker is operating a handcar moving 10 meters per second west along a railroad track. Okay. Cart is moving west. So west, that would be east. So it's moving this way at 10 meters per second. Okay. Here's a train whistle to the east of him. Train. And he hears the whistle, so this is observed at 655 hertz. If the train emits, so the frequency emitted of the whistle is 600 hertz. When stationary, find the speed of the train. So there is a speed of the train. And note if the train, and I don't know if it's moving this way or this way. And the speed of sound in air, so the velocity of sound is 346 meters per second. Okay, this is a problem about frequency and the change as things are moving. This is a Doppler effect problem. Doppler said the frequency observed is equal to the frequency of the source times the speed of sound plus the speed of the object or the observed frequency divided by the speed of sound plus the frequency of the source. Okay, so that's the work I have to look at. Let's see what we have. We have frequency observed. This is my f of o. This is the frequency of the source. This is the velocity of this is the thing that observed the sound. And this would be the velocity of my train or the velocity of the source. Okay, so let's plug in my numbers. 655 hertz is equal to the source of 600 hertz. The speed of sound is 346. So these pluses or minuses, I actually like to write the equation plus or minus. We have to decide upon them, so we'll come back to it. 346. The speed of the observer is 10. The speed of the source is unknown, so we'll write v of s. So in this case, if this wasn't moving, which we have it drawn that way, this is moving away from the source. Moving away should decrease the overall frequency, which means this value is minus on the top. This would make this a lower overall number. On the bottom, I don't know what it is. If I don't know what it is, a good rule of thumb is to put it as positive, and let's evaluate it and see if it's negative or positive and what's happening. Okay, so now we need to plug our numbers in and do some math. So our first math would be, I would do 655 divided by 600. That would be my first mathematics step. In that case, then, I would have on the top here, 336 divided by 346 plus the velocity of the source. So 655 divided by 600 is 1.092 equals 336 over 346 plus velocity of the source. I'm going to divide both sides by 1.092, multiply by the entire bottom or denominator, basically switch these, and I will get 346 plus Vs is equal to 336 divided by 1.092. Now we just solve for Vs. So 336 divided by 1.092. So this is 307 minus 346 gives me negative 38.2. Okay? This is the speed. So I have the numerical value of 38.2 meters per second. Now the question is it going towards or away from our individual? Okay, and so that's kind of a challenge to this aspect. So the way I wrote this problem, leaving this as a positive, I have a positive or negative option to it. So this wants it to be negative, okay, by the work to make this work out. So if this was negative, that is a situation in the denominator where this object is moving towards my option, which would make sense. I need something that would increase the total frequency. It moving faster would give you a higher value. So this is going to be moving west. And there's your answer. Good luck.